Okay, thank you everybody for coming this late in the day. My name is Tal. I'm an engineer at Google, a lowly engineer. I'm also a co-chair of SIG number 2, SIG automation in Nephio. So this talk is related to Nephio. I'm going to start with spilling the beans very quickly about what this whole talk is about. And I'll say I've written an article that will be published soon, which is kind of about this topic, and I wanted this to speak to it, but also be complementary. So wait for the article. It'll give you kind of the other half of this. Here's the point. Here's what I want you to get out of this talk. Code and data, right? I think we're all familiar with object-oriented practices, the idea that we encapsulate code and data together, right? Encapsulation literally means enclosing together, putting together in a closed space, right? We use it to refer to kind of the static design issues in object-oriented languages, right? It's something that comes from programming, right? You think of data, you think of code, properties and methods together. They're entangled together and create something new called an object, right? That is greater than the sum of both. We all know that. I want you to think about something new, a concept that I'm calling cohabitation, which I think is an alternative to encapsulation and probably much more useful for the kind of ways that we deal with data and code at a large scale in orchestration. Right? So leave encapsulation behind, that's what I'm asking you to do, and start to think about cohabitation, which is about code and data living together rather than being entangled together. And I'm going to give you some, I'll develop an argument here, and I hope it'll make sense to you. And the idea of cohabitation comes not from the world of programming, but from the world of operations, where we care about life cycles when things live. And to be honest, if you talk to the people who invented Smalltalk, the language, and kind of started the whole object-oriented revolution, even they say that object-oriented stuff is not about objects, it's about message passing and life cycles. So this slide, I apologize. I myself am an atheist. I thought it would be nice to give a quote from some cultural heritage that will be well known. But the metaphor here is that we have code and data cohabiting, living together in peace, and we are more coordinating between them and making sure that they don't eat each other. But I'll start with this. So there have been a few trends in recent years about something as data, something as code, right? Infrastructure of code was a big revolution, IAC. Then we started to hear about infrastructure as data, configuration as data, which is one of the core philosophies of Nephio. And I can tell you that I got a little bit confused. Okay, what is the difference between infrastructure as code, infrastructure as data? How are they different from each other? I'm here to tell you that they're not actually that different from each other, right? The big shift has been where we say something as code, we're talking about data in both cases, right? It's always about data, but it's two subtly different kinds of data. When we talk about infrastructure of code, we're talking about imperative configuration data, right? Scripts, workflows, playbooks. And we're talking about the engines that run this kind of data are things like Ansible or BPMN workflow engines. When we shifted to talk about a new trend, right? Infrastructure as data, configuration as data, we're talking about declarative data specifically rather than imperative data, right? So we're looking at different kinds of data structures and different kinds of engines. Kubernetes and Terraform are two great examples of declarative engines, right? Unlike Ansible, right, which is an imperative engine. Do you guys understand the difference? Imperative being like kind of run one by one a script, whereas something like Terraform or Kubernetes take the whole data together and they decide what the order of things is going to be. So that's kind of the shift that's been happening. Now, if you're living through this now and you're an old timer, you might think immediately, well, we've been through this before, right? Moving towards data, right? This kind of, let's take everything and turn it into data. I remember middleware, right? The idea of middleware was that we would take some off-the-shelf engine, and that has all the code in it, but we would provide it with data to configure the code, right? So as I point out here, it's data in the aid and in the service of code. the idea we don't have to recompile our whole software because we can just reconfigure that software with code. Nice idea, right? I don't know if all of us have good memories from that. I sure don't. It was very, very complicated. This was the era of XML, very, very large files and configurations to configure the code. Practically, to configure one of these engines, you would have to be a programmer. And whether we did ourselves any favors in writing XML instead of C++, I don't think so. It ended up being just as complicated. We ended up having, well, hard things could be done very simple with the engine if it was very much designed for it, but it made doing simple things very, very hard, right? Something that you can change in a line of code in C++, but instead you have to dive into XML and configure it according to the crazy ways in which this particular piece of software works. So you can say, okay, we've already done that. It didn't really work so well. Why would we want to do this again, kind of with this infrastructure as data, infrastructure as code approach? So let's examine it critically, right? What does code mean here exactly, right? I'll separate between two kinds of code that we know about, right? So I'm purposely using adjectives here to kind of bias you, but you know, there's the cool new kind of code that's very data-like, right? It's editable. It's mobile and portable, right? Think of languages like Python, like Ruby, like JavaScript that for some unknown reason suddenly became popular again, right, with Node.js. These are languages that are interpreted, right? They're dynamic. We can edit them on the fly. We can move them around because it's just text files. They can run here, they can run there, right? That's code that I call data-like because at the end of the day, if it's a YAML file or a Python script, they're the same format, but they can actually move and run together. You can store Python in a database, right? You can move it around. You can copy it as a file. You don't have to recompile it. Data-like code. And then I'm contrasting that to the old boring code, right, that you have to compile, that's proprietary, that's closed. Sometimes you need a license per machine. It's not portable. It's not mobile. Well, I was biasing you on purpose because I actually think that we're moving back a little bit, and I'm grateful for that. You've probably noticed the trend that a lot of us are rewriting a lot of our Python code for the cloud in Go instead, or even Rust. We're moving away from these dynamic interpreted languages and accepting kind of old-style languages, right, that were compiled, the old crusty kind of languages. Why are we doing that? And if you ask a lot of engineers here, it's a breath of fresh air, where we're actually improving the quality of our code, and we're not losing anything. Why are we not losing anything? I'll argue that the reason we're not losing anything, that we weren't really using those dynamic aspects of that code, right? The kind of cool new data-like code. We're not taking Python code and editing on the fly, right? Nobody does that. That's not a way to maintain quality. We're not taking Python files and copying them somewhere and just running them, right? So the whole advantages of this dynamic interpreted code are not actually important to us. That's why it's absolutely fine to move back to the old compiled languages. In fact, many of us are welcoming it, right? And other things are kind of disappearing from that cool trend, right? Object orientation, nobody really talks about it anymore. There's been a lot of criticisms of it. These languages, Go, Rust, are not object-oriented languages, and we're happy about that. Object-oriented seems to belong to that old kind of middleware approach of widget-based programming that seems to be inappropriate for the kind of stuff we want to do. All that big XML is dead. I'm happy never to see a line of XML code ever in my life again. YAML has kind of replaced it as this tiny little cool thing that doesn't even come from a standards body. It's just some guy created this. YAML stands for yet another markup language. It's been kind of standardized, but we don't care. We want tiny little things that do the job instead of big, very hard to configure stuff, because we don't need that old portability and standard-based approach anymore. And I need to, this is one of the more controversial slides, right? So in this trend, moving away from the kind of from what used to be cool and new and portable dynamic to more traditional kind of compiled code, we have GitOps. And GitOps, I think, is an interesting kind of anachronism because on the one side, on the one hand, it's exactly what I started this talk with, right? It's about cohabitation. What's lovely about GitOps is that we can have code and data side by side in the same place, living together, right? So let's say we have, we're deploying 10 different sites. We have 100 different microservices. I'm talking about kind of a very typical enterprise company, right? Every microservice can have its own directory in the Git repository, and that directory can have its source code, its build script, its tests, its Helm packaging, and its deployment script. And it's all in one place and under the same Git commit, so you know that it's all been tested and worked together, and it's easy to go back to another version of your whole site, right? So doesn't that sound exactly like what I was advocating, right? Cohabitation. I'm saying it's the wrong cohabitation story because the fact that the source code there is not the interesting part, right? What's interesting about cohabitation is operations, is where the code runs rather than where the source code is. Source code is compiled, it turns into binary code, that's what you run, right? In terms of the everyday operations, you're not going to be looking at the source code. There's a very small group of people in the organization that are looking at the source code, changing the source code under a very strict process of approval, testing it, and then it's being published, right? Code and data are two very, very different things, and they behave very, very differently. And I think in conflating the two, I think we're not doing ourselves any favors. I'm putting a side note here. I'm kind of a well-known, I guess, GitOps skeptic. Git is a great tool for storing source code, but when we use it to store data, we're really pushing it to its limit. I believe data should live in a database. Here's my rule of thumb. Don't move data, move code instead. All right, let's examine that, and why am I suggesting that? For orchestration to scale, we need to delegate. Right? We can't centralize all our operations in one place. As our network grows, right, that means that our center will have to grow. And we'll have to move data to the center, and by the time we move it to the center, it might already be irrelevant. We need to respond today very, very quickly to failures at the edge. When we have 100,000 edge sites, 1 million edge sites for some operators, centralization just doesn't scale. It's all about delegation. And the idea is to have the code running wherever the data is. If you have data at the edge, that's where you should run your controller, right? So Kubernetes makes it great because it's an extensible orchestrator, so you can run an operator over there at the edge, right? And if you have data that needs to be at your headquarters, run it at your headquarters, right? So if you need to deal with catalogs and inventories, which are at your center, right? They're not located at the edge, run the code there. So ask yourself first, where's my data? Usually there's a very easy answer to that. That's where you should put your code for that data, right? Very simple. I'm saying very simple things, but I'm amazed how sometimes we don't actually think about them. Very quick, something in parentheses that I'm not going to talk about today. I'll talk about in the next ONES, which is topologies. Topologies, I think, sit somewhere in between the headquarter and the edge, because on the one hand, we design topologies very carefully, but we want to allow them to adapt on day two. So they end up living somewhere between the edge and the headquarters. They're both design and emergent. So topologies are an interesting topic I might talk about in the future. So everything that I said until now, this is kind of the punchline slide, is what we're doing in Nephio, as I understand it. One very straightforward principle that we have in Nephio that I think nobody disagrees with is that we are declarative. We deal with data, and it's declarative data only. So not imperative data, not Ansible playbooks, right? We're only dealing with Kubernetes resources that need to be reconciled by code, right? So we are forcing you, right? The entry point into Nephio is that if you want to play the Nephio game, if you want to work with Nephio, you're going to have to think about data and code being separate. You're designing your data, you're designing your models, and then you have to design the code that will reconcile those models, that intent, with reality. So whether you want to or not, you have to kind of follow my guidelines here, right? And where would that code run? Well, wherever the data is. This is how Kubernetes itself works. So what you can do is schedule things around, copy data from here to there, right? And it's part of what we're doing. If you're starting at a management cluster and you're deploying it somewhere, and let's say you're using a Git repository as the entry point, yeah, you can move it there. But the code to actually use that data has to run wherever that data goes, right? So if you're using a custom resource that goes to one of your million edge workload clusters, there has to be an operator there that would know what to do with that data and actually reconcile it. So simple rules of thumb here, right? Where is the data? That's where the code should run. That's where the code should live. But there are challenges to this. Like, I'm not going to pretend that this is all trivial, right? For one, it's not always obvious where to put the data, right? As I said, topologies sometimes live somewhere in the middle, right? And we sometimes have also options, between the edge and the headquarters. There are regional areas that sometimes might be able to operate for some of that. And I'm also not saying much about observability and what happens to the data that we actually collect from the edge, right, and where that goes. So challenges, it's not trivial. The service assurance use case that I'm mentioning here, which is under development in Nephio right now, is a great example of it, because it's fine-grained data, right? So on the one hand, we want to respond very, very quickly to things that happen at the edge, but sometimes we can't respond at the edge. So the rule of thumb, I think, is still there, and we should still follow it, but we need to think about when exceptions should happen, right? So giving here an example of how this could potentially look, right? So we deal, day 0 starts in the center. That's where our templates and blueprints are. So that's where we should run the specialization code, exactly what we do in Nephio, right? And for day 1, when you deal with the actual deployment of these custom resources to the workload clusters, that's where you run operators there. Again, exactly what we do in Nephio, or at least we encourage to do in Nephio, and hope to provide an SDK to make it easier to create these operators, right? And I mentioned, you'll see that kind of final loop in the end, and I'm saying, well, that's not desirable, but sometimes we need to do it, right? We'd rather solve all the problems in the edge at the edge, but sometimes we do need to go back and kind of redeploy our entire process and redo the topology according to data that we don't have in the edge, right? Maybe we need to go back to the inventory and look for a different site, for example, side by side with us, or reconfigure, redeploy our site on bare metal, right? So there are certain things that you need to go back. But my point is there's a parsimonious principle here, right? We always start with the idea that the code should live next to its data. And only when that can't work well enough for us do we go elsewhere. So if we stick to that, I think we maintain very, very short delays. We ensure scalability, right? And we also minimize the surface area for errors, right? As well as security, right? Because if the center becomes small, the smaller the center is, the less things can go wrong there, and the more autonomy the edge has. I'll also mention, a lot of excitement about AI and what it can do. The autonomous edge, if I go back here, oh, I have one more slide. So this is where I put it all together. So the autonomous edge is where we can actually have AI respond according to the policies that we put in place there. Right, and I think in the keynote today it was mentioned, one of the, why is AI, we've been doing AI and neural nets for years. What's special about this moment in time is the economies of kind of hit there, right? We can run AI on a Raspberry Pi for $5, right, at an edge site. Something wasn't easy to do before, right? We have tensor cores running in our phones right now, right? So we have the ability to actually pretty cheaply create very powerful autonomous agents running at the edge. We don't need the center. We just need to make sure that those agents have the data that they need to make decisions. So we can provide them with policies. But again, they're there. They're at the edge. They see the data. By the time it gets to a center, it's already too late. So this is a story about delegation. right? Moving code, not moving data. What is the center still for? I think the center still has a place. Well, as we said, we still need a center is where we have our inventory, our catalogs, our repositories. But the center is also a great place for coordinating between these pieces. Right? When you have multi-sided deployments, network services, something fails somewhere. That site needs to know maybe about the neighboring sites, but it doesn't have that visibility. That visibility might come from the center. So the center still has a role to play, but it's a much diminished role from what we see in a lot of the kind of pyramidal orchestration diagrams that you see today. If you look at Etsy Mano, right, the idea of there's a high-level orchestrator, orchestrators underneath, and you kind of spread out as a pyramid into the edge. I'm suggesting here a different model, which is far more collaborative and cooperative. It's actually the agents at the edge that have the power, and the center is more a hub for exchanging minimal information that is necessary for coordination. Sometimes they say, let's throw away the idea of the orchestrator, like the metaphor of somebody at the orchestra, you know, all the violins and all the cellos are here together. Instead, think of the center as a coordinator, right? A hub where we can exchange information. The real agents are at the edge rather than at the center. So I think I'm running out of time, right? Oh, no? OK. Well, I probably moved faster than I could, but that would be great because I'd love to have a discussion about this if there's any comments. I'm sure I pushed some buttons here. Yeah. Sure, please.
I mean, you pushed a few buttons there, and I think you're being very sort of definitive and sort of black and white in terms of not moving the data. I think there is some data that you need to move from the edge to the center in order to make big picture decisions. You don't need to move it all. There's lots of data that stays on the edge, and you're very autonomous there. That then, I think, brings, you know, the top sort of central orchestrator pushing out to the sort of regions and edges, and then further down. I think that federation with the model that you're describing here and the autonomy at the edges means that you can get so much more scale out of a centralized orchestrator, but you still need to have a view, a centralized view of what is out there, what is running, what is your network. So
Right.
you changed its role, but you haven't improved it.
That's true. I mean, I try to emphasize that I'm exaggerating on purpose because what I want to do here is a change of attitude. I want us to be parsimonious. I think a lot of times when orchestration projects start, the first rule is like, OK, first we have to collect all the data, put it in one place. That's our source of truth. Right? And I'm saying, no, that shouldn't be your starting point. That should be your end point only after you've exhausted everything else. So the parsimonious principle. Try not to move data unless you absolutely need to. If you're trying to solve a specific problem, yes, but only collect the data that you need to solve that specific problem. Right? We have sometimes really insane solutions where you're moving tremendous amounts of data to one place, making decisions there, and then moving it all the way back, right? And so some people say, well, OK, well, if your data is emergent and you're collecting data from different places at different times, time is a dimension here too, not just space, then you're never seeing a complete picture of the whole network. But I would argue that you never are. The idea of centralizing data in one place is an illusion, because there's always a delay between the data is there. Yes, the data might look very nice in your inventory that shows all the sites and all their characteristics, but it might already be wrong because you didn't get the data that's there. So you're always dealing with an image of your network that is incorrect. So if you start with the assumption that it is emergent, then you're able to make decisions that are more realistic than not, right? And we know of spectacular failures that happen because of this, right? Because if you solve all your problems in the center and you're not seeing the correct image, then you're making corrections, pushing them to the edge. The edge has already changed, because some of these take minutes, if not hours, to actually propagate. And by that time, the problem might have been self-solved, self-healed. And you get into these endless loops that self-correcting, that bring your network down, right? There was a pretty famous one not long ago. So yeah, agreeing. I'm saying this is about attitude, not about rules necessarily. Yeah. Please. Sure. Was there somebody else? Yeah, Alexei, please.
So in the mindset of operations, typically traditional telcos, right, I'm going to bring them in the picture, have their network or security operation center where they like to funnel all of the data to being able to do their security forensic, whatever, or network operations, kind of alarming, maybe, right? So are you suggesting that we now distribute that function, or it's how would you marry the actuals that exist today in the operations, whether security or network, in my examples, with the kind of proposal here? How do you marry the two?
Well, I think in order to reach the kind of scales that we're talking about, we need to be aggressively delegate. But again, you know, there are some things that you can't. But even then, you can be parsimonious, right? So if you want to have a single pane of glass, right, that's often talked about for your whole network, well, you don't need terabytes of data to do that. The single pane of glass doesn't show a lot of things on it. So you can, you know, instead of sending all the data to the center, then analyzing it and only taking what you need, you can already filter that out at the edge. The edge can send only what needs to be done for that specific task. I think we always start with this idea of collecting everything centrally and then doing something. And I'll say often that there are different ways to move data, right? If all you're doing is logging doesn't have to be immediate. It can take time. You know, archival data stores are not the same as like active data stores, right? So some things can happen kind of offline, slowly, with delay, with buffering. It's not too important. They'll eventually reach their destination. So we can put all that data elsewhere, right? So, but the whole point is like, don't use let's move the data as your starting point. That's really the main attitude that I'm trying to do. And now we have, sorry, what did the green sign say, sir? 3 minutes, all right. Yeah, please go, yeah. Is there any other hand up? Anybody? All right, Alexei has one more thing.
Yeah, so I have a follow-up question to this is, if I think more about typical service orchestration. So you create a service, then it instantiates, and that service usually is distributed. Now I want to do service assurance kind of use cases. So I want to understand really how the service is behaving end to end. How would I achieve this? Because you see all the components of the service might be distributed. For instance, I take a 5G core RAN, it's going to be distributed.
Right.
I'm the operations, I want to have that central view that you've been talking about a little bit. So I understand, is it a matter of identifying the KPIs that I want to centralize? Or maybe a little bit of understanding of the approach that should be taken? Right,
so you know, I get into the paper that will be published a bit more, but this idea of the coordinator, right? You can use the center to coordinate between sites. Coordination doesn't mean that they have to store something in a center database and then both access it. They can pass things directly to each other, right? And sometimes you also have regional data centers that could do part of the work as well, right? So, you know, every problem will have its own solution, but the idea is to start from the end and only move to the center where you have to. Every time you move something to the center, there's a huge cost in terms of scalability, right? Because it gets multiplied by the number of your edge site, orders of magnitude, right? So again, the parsimonious principle should rule here. Move only what you have to, and try to find every solution first before you do that, right? Because then you'll end up with a kind of very center-heavy networks that we have right now that I find sometimes very unmanageable. Yeah. Yes, Sagar. Sure.
So, I mean, in the beginning you said, you're a little bit skeptical about GitOps, let's say. So, and so far the way we are doing GitOps is more like centralized GitOps, right? A single source. Why can't we do, let's say, decentralized GitOps? Like every single edge site or a group of edge site or an edge or a regional site have its own way of doing GitOps. Then it's again, it's decentralized.
So GitOps is used in different ways, right? The way Nephio uses GitOps, actually, there's no code there. It's only for data, which I think is especially weird, right? But it's, I have 1 more minute left. And yeah, so if GitOps is meant only as a delivery system, then yeah, whatever. You can distribute them anywhere that makes sense, right? Farther away from the center, the better, in my opinion, right? But if you're using GitOps for the kind of old-style cohabitation of code versus data, you have your Ansible playbooks next to the data, well, then it doesn't matter. You're probably taking it from Git and then putting it elsewhere, because all of these are different subsystems. You have Ansible, you have Terraform. These things run somewhere. Do they run at the center or do they run at the edge? I say run them as far away as you can from the center, right? So where the data comes from, it eventually will have to move somewhere. Nobody uses Git directly. To use Git, you have to clone the repository. There is no direct access to Git. So Git demands that you move data, which is already a problem in my view. But yeah, I can go on and on about why GitOps is an issue, and I'm out of time. But I'd like to thank everybody for your patience with my weird ideas and controversial statements, and I look forward to continuing discussing with you here and in the context of Nephio. Hope to see you all on the Nephio Day on Thursday and Friday, those who stay, and thanks.